Recording in progress.
Okay, so as I mentioned, this is a new unit on polar coordinates and polar equations. And again, it's very closely tied to what we've done already. A lot of trick stuff's going on here. So I'm gonna keep it kind of basic today. And then the plan is we'll do as much as we can this week. And I might have to kind of have you guys probably watch some video lessons on top of this, what we do, just to kind of make sure we're covering everything that we're supposed to in a particular day. The next week, I just want to kind of sort of just take some time to kind of review this, understand what's going on here, how it relates to everything we've done. I'm planning on doing a short test right before Thanksgiving. And the reason why I want to do that is that when we come back from Thanksgiving, a lot of times when we come back from Thanksgiving, it's this whirlwind. Like, oh my God, I got a paper due. I got this, I got that, I got another test. And there's a lot of tests that first week back from Thanksgiving. I don't want to do that to you guys. I really much prefer we do a short test before we leave for Thanksgiving, come back from Thanksgiving, and just focus on finals. Just really, that's the only singular focus, right? The only focus is focus on finals and kind of just sort of just really sort of digest all the stuff we've done. That's kind of what I'm thinking. So anyhow, let's talk about polar coordinate system. So a polar coordinate system looks like this. It looks kind of crazy. It's a bunch of concentric circles. You can see it kind of looks like unicircle in a way, right? The positive x-axis is 0, and if you go counterclockwise, the angles start increasing, and they're using radians here. You can use degrees too if you wanted to, but typically we use radians when we deal with polar coordinates. But again, degrees are totally fine. And each circle represents a radius of length of an integer length. So the first circle that you see, kind of like a dartboard away from my think of it, but the first circle is going to be a radius of 1. And it increased by integers. So radius of 2, radius of 3, radius of 4, radius of 5, radius of 6, and so forth, right? We're going to plot these points in just a moment. But the way it's set up is that R is the first coordinate listed, theta is the second coordinate listed. So it's always going to be in terms of R and theta. Go Thomas.
Like the coordinate plane?
Yeah, exactly. Yes, this is the polar coordinate plane. Yeah, yes, exactly. If you want, you can call it that, or a polar plane. We just call it that sometimes. But yeah, polar coordinate plane. There you go. Now the pole is considered the origin. So let me get my annotation tools out. So the pole is like the origin. And the polar axis is kind of like the x-axis. So, and again, to graph a point of the polar coordinate plane, we stand at the pole and turn to face the angle. So the pole's right here. It's right there. And you turn to whatever angle you want to go to. So let's say you want to go to 5 or 6. So like you stand at the pole, you turn towards 5 or 6, right? And then you walk out a certain radius. However, whatever the radius is, that's how far you walk out. Sometimes the radius doesn't have to be an integer, by the way. The radius could be 1.5. Maybe in between circles 1 and 2, right? Sometimes it could be that. It doesn't have to be integer lengths. But every circle represents an integer length, just so you know. Now, what if your theta is negative? Of course, turn the negative direction. But what if your R is negative? That could happen too. If the R is negative, you're actually going to rotate 180 degrees and then go in that direction. So we'll talk about that in a moment. Actually, we'll talk about it right now. So here we go. So example 1, a radius of 2 and a theta pi over 6. So I'm just going to plot a point right here. That's point P. See, I'm on the second circle and I'm at pi over 6. Now Q has a negative R value. So it's going to be like this. And that's what happens to that one. So that's just that's just the convention we have to follow. We have negative R values. You rotate 180. Once we kind of start seeing the connection between this and rectangular coordinates, you'll see why we have to do that rotation. Right now, I'm not ready to have that discussion yet. I think we will in a few minutes, but you'll see why. If you're asking, well, chemistry just said so, so I just guess I have to do it. There is a reason why we do that 180-degree rotation when R is negative. Again, it's when I connect polar coordinates to XY coordinates, you'll understand better why that is. Now plot the following points. So it should be pretty straightforward. Let me clear this. So A is gonna be right here. Sometimes my eyes play tricks on me, but 1, 2, 3, 4. So that's A. B, you go 3 pi over 4 and raise to 2, but you got to go the other direction. It's right here. 3 negative 45. So that's B, by the way. That would be over here. That's a terrible looking B. My apologies. I can do better. D, 3.5. That's interesting. So between 3 and 4, 7 pi over 6. Again, my eyes really play tricks on me here. 1, 2, 3, 4. So halfway between. That's D as in dog. 4 pi over 3. But negative 4, so I gotta go the other direction. And raise to what? Negative 4. So it's actually 4 in the other direction. 1, 2, 3. So it looks like that's identical to A, right? You guys see how those are identical? Because what's 180 degrees in radians? I know it's Monday morning. Pi, good. So if you add pi to pi over 3, you get 4 pi over 3. So it's a rotation 180. Yeah, go ahead. Did I make a mistake? I made a mistake. My apologies. It's just my eyes are playing tricks on me. That's all it is. My apologies. Thank you for catching that. F 6, 2. So 2 tens like 7 pi over 6. And it's negative, it's 6. Remember, D was at 3.5, so 4, 5, 6. And then G, 11 pi over 6, but negative 7. 1, 2, 3, 4, 5, 6, 7. Hold on. Over here? Am I at the right place? Yeah, I think so. That's G. So it should be pretty straightforward. I mean, you guys know stuff. So we know about point A and E. They're the same. Right? That's what we noticed about A and E. So questions so far? No? All right. Are the other coordinates that would also describe points A and E? Yes. And how many possibilities are there? It's infinite, yeah. Because you can go around many times around the unit circle, right? You could do like 4 pi over 3 plus 4 pi. You know, like as long as you do one rotation, or you could do all these negative counterparts too, right? That's a possibility. So yeah, good.
Could you like include your forward plane with as many concentric circles as you want?
100%. Yep. 100%. Totally. So yeah, they're the same, and the answer is yes. There are other coordinates that would also describe points A and E. And 2 of the points are there in the same location with R equals 4 and R equals negative 4. Well, I mean, I just said, you know, you go around once. So you can do like 4 comma 7 pi over 3. Gosh, that's terrible. Sorry about that, guys. Also you can do negative 4 comma. Yeah, thanks. Yeah, add that to 4 pi over 3. Thanks, Kieran. Yeah, good. So there are infinite number of ways. So find a generally represent all polar coordinates for B and C. So for B and C, you could say -2. Geez. Remember what we used to say? Plus what? Yeah, 2 pi k, exactly. Where k is any integer. Or for C, you can say 3 comma negative 45 degrees plus 360k. If you're doing in degrees, right? We're getting k is any integer. You can do that too. That's a possibility. Or you can also do negative counterparts, but then you also have to change angles as well. So you could say like 2 comma, what would that be? Negative pi over 4, I think. Yeah. Say, was that your question? No. Okay, go ahead.
Did you also do minus 3 by taking minus?
Yeah, sure. Sure, yeah. But remember, k is any integer, so that's already taken care of. Yeah, so. Okay, coordinate conversion. Okay, this will explain why when r is negative that you're going to have to do that 100-degree rotation. So it's really just basic SOHCAHTOA, to be honest. Let me make that theta a little more noticeable. So what's cosine theta? Great. What does x equal? There you go. Well, bless you. What's sine theta? So is y equal? So that's one way we could do the conversion. Another way you can think about it too. Let's see again. X squared plus y squared equals r squared cos squared theta plus r squared sine squared theta. What can you pull on the right side? And what's left behind? Right, because cosine squared plus sine squared is 1. We know this. So that's cool. It's not that much different than all the other stuff we've done, like with vectors and parametric and all the other stuff. It's all pretty much similar, right? Or the De Moivre's theorem, all that stuff. And then also tangent theta equals what, guys? Yeah. Usually I kind of just leave it like that. I don't necessarily write the inverse tan so much. I just like to leave that relationship there. And some you could just sort of just see, oh, well, if tan theta is this and theta has to be that. But if you want to write inverse tan, that's fine. But these are going to be your conversions. If you know what x and y are, use the bottom. If you know what x and y are, then you can figure out theta and r and polar. If you know what r and theta are, then you can figure out what x and y are using the top ones. And really what's happening here when I draw the triangle, again, there's a bunch of concentric circles, right? And ultimately, we're going to have a circle. Okay, I kind of just feel like that. Ultimately, like, or it might be between two circles, who knows? But, you know, you want this point, right? To touch, you know, a circle somewhere, some radius, and work it out, convert it, right? So it's that simple. Now, if your r is negative, right? What's that going to do to x and y? To make assuming theta is in the first quadrant, by assuming theta is in the first quadrant, if r is negative, then what x, y going to do? Negative. So they have to be in the other quadrant. You have to 180-degree rotation, right? You'd have to do that. That's what happens there. So we have to be mindful about that when we switch sign of r. It may not be terribly obvious sometimes when you're doing these conversions, but that's something you have to keep in mind, that you have to do that rotation if r is negative. Okay. So let's take a look at A and B. Yeah, for the most part. Yeah. Yeah. Okay. Yeah, and actually if r were negative, when you do yeah, solve for x, well, yeah, right. X, y have to be properly adjusted. So and of course, if your x and y are negative or positive, you choose the r theta values appropriately. So remember, you have to be mindful of the theta values as well. Oh yeah, I'll keep track of time for you guys so you have enough time to do the test. Okay, so let's do yeah, actually, for those who have to take it, let's say in 5 minutes, I'll get you guys started. Okay. And I'll just, you can just watch recording of the rest. Okay. So let's talk about converting really quickly. And then when I get to part C, then I'll take the other people outside. Okay. So converting, really simple, right? It's not that hard. You're just going to do x equals 3 cos 5 pi over 6. And y equals 3 sine 5 pi over 6. That's it. It's that simple. 5 pi over 6 cosine is negative root 3 over 2. So it's negative 3 root 3 over 2. And that's 1/2. So it's just 3/2. And then here, x will equal 8 cosine of 7 pi over 4. Now, just so you know the graphs of these, when we start graphing polar stuff, which I'm not sure if we'll do too much today, they get really kind of interesting and really kind of wacky. Some are pretty neat. Like you can actually graph like rose petals or other kind of cool shapes. So it's kind of neat. You can really make some interesting graphics with these. 7 pi over 4, that's root 2 over 2. So it's 4 root 2. But one's negative because you're in the fourth quadrant. So does that make sense? Then going the other way around, r squared will be negative 1 squared plus 1 squared, which is 2. So r is root 2. And what's your theta going to be? Well, you have to be in the second quadrant, 3 pi over 4. By the way, you could have negative root 2, comma, negative pi over 4. That could have worked also. Here, negative 3, comma 0. I think it's pretty obvious. What's r going to be? And what's your theta going to be? You're on the negative x-axis. Pi, so 3 comma pi. You don't really have to think too hard about it. So that's why I think we can get away from making this a short unit, because it's just so close to how we've been doing for the last few months. So a lot of method to this madness, right? With like all the stuff we're doing. You know, we kind of reviewed all the trig stuff September and October, did a lot of new stuff recently, and we're just adding on to this. But you know, there's going to be some interesting things we'll do down the road. And by the way, in AP Calculus BC, you do have to work with polar coordinates sometimes. Like you'll be given like a situation where there's a polar equation, you got to do some calculus stuff to it. AB class does not do that. The BC does. This is the one of the big differences between the two. And the way you go about those calculus principles varies a little bit, depending on how you compare it to the X and Y coordinates. So you have to be fluid with all this stuff, or fluent, if that makes more sense. Lastly, this one here, 3 negative 4. So that's going to be like right here, right? What's your radius? I think it's pretty easy. 5. And your theta is going to be the inverse tan of negative 4/3. Now we do have to use a calculator here. And I think I've decided, I think I'll make our next test calculator allowed. I think that's probably a good idea. Well, there's some things or maybe a Porsche will have a calculator. Make sure I'm radian mode. Okay, I get negative 0.927. I can leave it like that, by the way. I don't have to change it up to be 0 to 2 pi. That's totally valid. You can leave it like that. That's totally a-okay. And by the way, let's just get in the habit of doing 3 decimal places. That's how the AP is done as well. It's 3 decimal places. Okay. So we're gonna now start doing some graphs. This is where it gets a little fun. And just look at the pacing here. Ooh, this gets really fun. Look at this. We'll see how far we can get. I mean, if I can get part 1 done, I'd be so excited. But let's see. Because that'd be lovely to be done teaching new material by the 14th of this month. Like, it'd be so cool. And then we can just review. Anyway, let me get the other people started on their tests, and I'll be right back. So,
Should we do it?
if you want to give it a try, I'll be right back.
Yeah, and then very good.
talking about, I think this is like all there is. I think that might be really a thing about everything else. No, he's very talking. Yeah. Dorkin, it's that simple. You're overthinking everything.
So then what is the graph on how it goes?
The line at that point. Yeah.
We talked about this a little bit. So I will acknowledge I kind of screwed up with number 7 part C. I was my intention. So what happens when we wake up early to do the very test? Hold on, I'll show you really quickly here. Where the heck is it? Oh, there it is. Duh. Okay. Yeah, my intention was that the number 7C would have factored. And I think what had happened was I think I intended this to be plus 16x. I originally had a different equation that was a little bit shifted more to the left, but the quadratic was really nasty. So I changed it up a little bit to make it a little bit more tolerable. But I forgot to change one of the. But if you did rewrite correctly and you did graph correctly, you would have had a parabola and ellipse that don't touch. So you should have anticipated no solution. But regardless, I'm gonna give everyone full credit for 7C, just so you know. Everyone gets full credit for it. Okay. And even then, I may still even do a curve. I may still do a curve on top of that too. Okay. But I will say this though. Okay. The one thing that I am kind of asking you guys to do a little bit is, because again, I am trying to get ready for that next level. And I don't know who's teaching AP Calcs BC next year. I have no clue. What I do know is I've been in school for 20 years, where whoever's taught that class has really held a very hard line. So Ms. York totally holds a hard line. The ones who taught before, likewise, same thing. The one taught before that person, same thing. And so I'm just trying to get you guys ready for that. So sometimes you're going to see some problems that we haven't quite, like, I've never presented a problem like this to you before, like in this manner. I've never done that. But we have written equations of these things in parametric form when I give you other information, like when I gave you like the foci or the vertices. We had that on the review. So if you could do that, you just have to just kind of take that principle and apply it to this, right? Recognize the fact that, hey, wouldn't the intersection points be the center, right? It's not that hard to find. I know you guys can do that, just substitution. So now you got your center, you're halfway there. And then the area of the central rectangle. Oh, Ethan, you haven't taken it yet. Shit. God damn it. No, it's my fault. No, I'm sorry at myself. I'm sorry at myself. No, I'm not mad at you, Ethan. Yeah, no, but they're taking. Yeah, I did, but that's because you took it much later. That's why. Because you might just walk in the hallway. I'll change some of the other problems for you. Just okay. No, it's my fault. Okay. No, I should have realized it. That's my fault. It's my fault. Okay. Thanks, Ethan. Okay. All right. Oops. That's a big oops. Okay. All right. This is what happens when a school like this, with so much stuff that goes on, like everyone's got fill in the roof, Alpha cross country. It's like we got too many programs at school. Anyway. Okay, area central rectangle. That was a little tricky though, I will admit. But we do know that 2A and 2B are the dimensions. So 4AB has to equal 32. Once you see that, and then also recognize the fact that the slope of this is 1 or -1, so A and B has to be equal to each other. So you can easily solve this by making 4A squared equal 32 and solve for A. So once you have that, you're good. And no x-intercept's got to open up and down, not left and right.
So it was a
You don't- Yes, it was. Okay, number two is very, very simple. We've done already. I've given you guys lots of practice like this. But some of you guys mixed up the focus and directrix. You guys said it was like 4p. It should be 2p between the focus and directrix, not 4p. So 2p equals 10.125. So 4p equals 20.25. Now, if you left in terms of radical, that's fine because it did come out clean. It came out to 90. If you actually want to go to Stanford and do it, you can measure it if you want. But it comes out to 90 feet is the answer. But if you left it as a radical, that's fine. That was a little too tough to do that calculator. 3 should have been really simple without a calculator. I even said leave it in radical form, inverse trig form. 4 very very for I don't anticipate this being a problem. It's very very black and white. Now this is the mystery problem. The mystery problem what's happening here. It was C, I think. No, wait. No, wait. Wait, hold on. I don't remember.
You multiply out the I goes.
If you were to make coordinates for
I'm just working it out. Hold on. Just chill.
and then you pull out I, Yeah.
Yeah, so it becomes 3. No, it's A. It's A. It's A. It's A. You pull out I. Yeah, but no, but you pull the I out though. No, it's 3 plus 2I. No, it's A. The answer is A. Yeah.
You just do it without A plus BI.
Okay, for third.
Oh my god, 41.
But again, we did talk about quarter place, but you have to use strategy. You have to use strategy where I came with a hypothetical value for W. Okay, for B. Okay. We did talk about weights and factors. I've never given you a question like this, but you do have, and I'll say this, you do have to know your ground principles. Like as you guys do test prep for like FPA, which I know everyone in this class is doing, you guys would probably be finding that rigorous colleges and you need to do these standardized tests. You gotta know the triangle inequality theorem. You guys forgot what that means. The third side of a triangle has to be less than some of the other 2 sides, right? Although the triangle collapses. For vectors, however, it can be the same. Like for example, these 2 vectors go in the same direction, so it could add up to 28. Or if this goes in the opposite direction, then we do that minus that, or that plus is negative, it would be 8. But 7 is not possible. So you still have to know these principles, which is expected in AP Calculus. So you have to know these things. And for 41. You weren't there. I know. That's why I have to think about. I know. I get that.
I still really don't.
Okay. Okay, but here's the thing. You did learn it in geometry. I know that, but you forgot, of course. You forgot. I know you forgot. Or 8th grade for some of you. So let me see how this question goes, and I'll see if I could do something about it. But no, I'll just let me think about it. Let me see how it goes first.
Try again.
No.
Tell me what
It's just a segment that goes through a circle. That's all. It just accords this.
through a circle.
Yep. That's it.
Oh, the common part. So it's just anything that goes through both of them.
Yep.
The 2 points of intersection.
Wait. So then,
Here.
if the only requirement is that it goes through both of them, like is that?
So that's your first circle, and then the other circle looks like this.
No, I understand what you're saying, but does that not mean that this is a chord because it goes through both of them?
No, it has to be common to both.
Why couldn't it be like?
Meaning, it has to go through them in the same amount.
Yep.
Yep.
Yeah, the word I mean, again, a lot of the geometry terms, again, you are expected to know on the AP. So again, I'm just trying to get you guys ready for it. But if you guys struggle with that, I could talk about it. I think I'll talk about everything else for the most part. So anyway, Zay, go ahead. Yeah, let me look at it first. I've only graded a handful of tests so far, so let me look at it first. So okay, anyway, let's get back to the notes, guys. Okay, I know you guys are eager to hear about it. It was good for me to give the feedback. Again, everyone's gonna get full credit for 7C, and I will consider a curve if I have to. So yeah. I want to see the responses first. Yeah. Oh, wait. I didn't talk about it. Let me go over that. I didn't go. Hold on.
I thought that was.
The only way I've heard of actually solving it was someone assumed something.
Hold on. I forgot to talk about.
Yeah.
It took way too much time.
Okay.
Yeah, it took too much time.
You have like-
Where does it say?
Okay. I will say.
Oh, this one is so much time.
It was what?
Damn, that means you definitely can tell.
So,
You guys quiet, please. Thanks.
So you know that the first x-intercept is 3 times the other one.
Yes, good.
So you say, or so call them A and B.
Perfect.
So you say 3A equals B
Perfect. Love it.
and B minus A equals 4.
Guess
Then you plug those in and then you can get 2 and
Six.
6.
That's huge.
I got that.
You gotta start there first. So what's H then?
Oh, yeah.
8, what is
The X score in the center.
Oh, then,
4.
yeah, because you know it's in
Okay,
between.
so you're a quarter of the way there.
Uh-huh.
So you get
Actually, you're driving, can I keep going?
actually you're a third of the way there. Keep
Yeah.
going.
And then, you know that, it being, that the line being changed from a circle at 6, 6, means that there's a point at 6, 6.
Good. Okay, guys, you heard that? There's a 0.66. So now you have this. You have x minus h squared plus y minus k squared equals r squared. Just so, hold on a thought for 1 sec. Okay, so you have 6 minus 4 squared plus 6 minus k squared
Because 4 is in the middle of 2 and 6.
because of symmetry, right? Circles have symmetry, right?
And how do you know that?
Because you know it's between 0 and.
Because the distance of the x-intercept is 4 and one is 3 times the other. So if you say if you make an equation, a minus b equals 4 and a equals 3b and substitute and solve, you should get 2 and 6 for your x-intercepts. Just make a system of linear equations based upon bullet points 3 and 4. So if you just set it up, you should get like a minus b equals 4 and a equals 3b and substitute. Let me grade it first, guys. Let me grade all of them. I haven't even seen G periods yet, so let's wait. Once you have that, then this is where it gets a little tricky, but keep going, David.
Then you know that since you have 0, 6, and 6, 6, then you know that the x value of the center is going to be 3.
No, it's 4. X value is 4. We already talked about it. The y value is 3.
Sorry, yeah.
But so
This is so easy.
wait. So why are you saying it's 3? No, there's a process for that, but why are you saying it? You're right. It is 3, but why?
Wait, what are you saying?
Why is K 3? Zay, you want to step in? Yeah.
I do, I do the same thing as David. I got X value is 4.
Good.
What I
Okay.
did is, I knew that there would be a line from the radius that would be opposite the circle.
Thank you. Yes, you guys need to know that. Yes,
I think the slope was negative 2/3 for the
Correct.
tangent line.
correct.
So the other one was gonna be 3/2, and
Good.
if you kind of drew that line, then your center would be at 4.
Yeah, what's going to happen here is that's the equation. So your the slope of the radius is going to be 3/2, right? Okay. Well, here's the thing. What's the equation for slope, guys? Change in y over change in x. You'll find the slope. So this slope here has to be 3/2. So you have 6, 6, and what's according to the center? 4, k, right? You can solve for k now. K minus 6 over 4 minus 6 equals 3/2. That was the invisible connection. Once you see that, smooth sailing. Then you can get K, you get R, and you're done with the problem. If you don't see that connection, you can't, you're stuck, right? Of course you're gonna be stuck. This connection,
Wait. Don't you only, don't you?
or you could draw it. As you could draw it too.
Wait, if you have the 3 points and you know that the center is equidistant, solve them, it's not enough.
Yeah, exactly. That's radius.
Yeah,
Oh, did you use distance formula?
yeah.
What distance? But you don't know the distance though.
Wait, look, if you have these 3 points on the circle, right?
I need. Hold on. I'm talking about.
Wait.
I need to get. Okay, guys, I need to get back to the lesson, but really quickly, guys, quiet, please. David might be on to something else I need to check out, but what Zane and I were talking about was this here. So this connection, that skill is what I'm gonna try to work on with you guys. I think we need more practice of like seeing these invisible connections that are not, which you guys know. I know you guys know slopes. If I told you hint, find the slope, you guys would do it. I think most people get this question right. But I can't tell you that because that's the expectation of a pre-calculus BC honors class and AP calculus BC. You're gonna see AP problems that you're like, okay, I have no idea what the connection is, but I have to teach you guys to start looking for that, to unearth it, to take things that you already know and connect it to other things that you know as well, but you've never seen that connection before. That's what I'm trying to test you guys on. And that's when you get rewarded for those things. And so that's what we have to work. And if you're having a hard time seeing it, I totally get it. It's not easy to see. But this is what makes us different than the other two levels of pre-calculus. This is what makes us unique. So we're gonna keep working on this. I'm gonna keep putting questions like this. So anyway, you can come in, Ethan. I'll close it. Okay. All right. Thanks, Ethan. I appreciate your patience. All right. Okay, so I'm gonna change a couple questions for you because it just cuts. Let's keep moving, guys. Sorry about that. Let's get back to graphing these. All right, here we go. All right, so r equals 3. What does this mean? This means x squared plus y squared equals 3, right? That's all it means. Actually, I took it back. Equals 9. My apologies. R squared equals 9. So x squared plus y squared equals 9. So you just draw a circle, that's all. That's it. That's all you do. Okay, here, it's basically you can think of like this. Y over x equals tan theta, right? So y over x equals what, guys? What's tan pi over 4? Tan pi over 4? It's just 1. So y equals x. So really just graphing this. Yep. Those are both directions. Because y would still equal x in the third quadrant, right? On that line. That's true. So clear this is a circle. And clear this is a line. So not terribly obvious, but when we connect it to rectangular coordinates, we can see that it is obvious. But you have to start thinking this way, especially as you move on to AP Calculus BC, like when you start doing calculus principles with polar coordinates, you got to recognize, oh, if r equals a number, it's just a circle. I know it's not obvious. Or if theta equals a number, oh, it's just a line. Because for so many years, you've been trained to think rectangular coordinates. You've not been trained to think this way. So in general, when this happens, it's a circle. In general, when this happens, it's a line. Okay, let's keep moving, guys. All right. Okay. So we could actually graph this in Desmos. It might be better, I'd say. I don't know if I'd want to use the TI-4 calculator. Desmos is a little faster. So let me pull up Desmos right now. Hold on. It does. Yeah, I just gotta search for it. Desmos is slowing down my computer. Okay. What the heck's going on here? Okay, here we go. So if I do r equals cos theta, you just get that. Just a circle with the radius of 1. Sorry, radius of half. So when you graph that, it just looks like this. do you have a question? Okay, no worries. Yeah, so if you just graph that, you just get that. And it kind of makes sense because if you think about it, if I square both sides, I would get this, right? And you could also, actually, let me take it back. I lied. If you multiply both sides by r, my apologies. If you multiply both sides by r, you get this. What does r squared equal, guys? Was r cos theta equal? Just what? Just x, perfect. What is that going to be? A circle, right? And if you were to complete the square, how do you complete the square for this one? You have to add 1/4, both sides. Why am I adding 1/4? Half of -1, which is -1/2, and square, which is 1/4. So you get x minus half squared plus y squared equals 1/4. What's your center? 1/2 common 0, and what's your radius? 1/2. So that's why that should make sense, right? So you're gonna expect something pretty similar for r equals sine theta. Actually, I'll just kind of tell you right now how it looks. It's gonna be another circle, but how's it gonna be oriented? It's gonna be vertical. Yep, it's gonna be vertical. Meant to switch colors. My apologies. That's because if I multiply both sides by r and r squared equals r sine theta. X squared plus y squared equals y. You can get the same exact thing, but it'll be a different orientation. It'll be x squared plus y minus half squared equals 1/4. Okay. So as you can imagine, what do you think is going to happen for the next two? It'll just be a bigger circle. It'll still be the same orientation, just with the bigger radius, right? So if I were to show it to you in Desmos, see, it just gets bigger. Or if I do 3 sine theta, just get that. That's all. So it's pretty simple. Now it's -2 cos theta. Yeah, it should be reflected. So we see patterns, just like we did for parametric equations, right? We see patterns. Like, so if I go really quickly, if I make that like a negative, see flips, right? Or if I do -2, flips, right? Very simple. So in general, we can generalize and say, well, okay, they each produce circles. A circle where symmetric. Sorry. About the x-axis. And k is the diameter, by the way. And same thing here. A circle of a symmetric about the y-axis. That's the only difference. And both touch the origin. Or pole, as we like to call it. Both touch the origin of the pole. So to convert, it's pretty easy. Like just multiplies by r and r. R squared equals 4 cos squared theta. Sorry, 2r. Jeez, I can't believe I did that. 2r. So x squared plus y squared equals 2x. If you move things around, you should get this. So it should, you can add one to both sides. You should get x minus 1 squared plus y squared equals 1. Here, multiply by r and r. R squared equals -3 r sine theta. So x squared plus y squared equals -3y. Take half of 3 in squares, 9/4. So yeah. And that's how you can figure out what the center is, what the radius is. So it's not that hard. It's 9/4, my apologies. The radius is 3/2, of course. They're making a mistake? Okay. So again, there's just patterns here we're seeing. But multiply by r and r, that's kind of the best approach when you convert the polar equation to rectangular form. This one's actually asked us to kind of go in deeper, a slightly deeper dive. But let me yeah, I think we could probably I think we could do example 6 and 7 I could just briefly talk about, and then we'll just stop there for today. So anyway, for r equals 6 cos theta, describe the graph. I know it's a circle with diameter of 6. And it's going to be a horizontal orientation. So see the pole 1, 2, 3, 4, 5, 6. It's kind of hard to draw the rest. I mean, you could just kind of just sort of just do a quick sketch, but if you want to be more precise, we probably should plug in some values for theta, right? Like maybe pi over 6. So here's theta. Here's r. Maybe pi over 4. Maybe pi over 3. Pi over 2, I already know it's 0, so don't waste time with that. 2 pi over 3. 3 pi over 4. And of course, we'll do 5 pi over 6. Well, pi over 6, what's the r value going to be? That's going to be 6 root 3, right? No, sorry, 3 root 3, my bad. That should be 3 root 2. And then 3. So pi over 3 and 3. That's easy. Pi over 4 and 3 root 2 is like 1.4 something, so it's probably about 4.5, I'd say about. And that's like 1.7 something is 3, so multiply 3 is like 5 point something. So it kind of looks like this. And then these here are interesting. They're gonna be negative values, right? Because cosine is negative in that quadrant. So you have to reverse it by 180. So it actually comes down over here, right? And it's geez, it's covered, but probably over here, somewhere between these two. And so over here. So yeah, kind of like that. So that's, you can kind of make it a little more accurate just by plugging a few extra points. Yeah, Kieran, good. And we'll stop there for today, guys.
Oh, no.
Yeah, I'm gonna have you guys watch a video on the rest of it. I do have a video I made last year on this. So I'll have you do that and then do the problems. The homework packets, let me get that to you guys. Not all of them are whole, staples, our copy machines suck in this building. So if you wanna hang tight, I can, staple.
Yeah.
Really fun.
You're about 6'5", Doug.
And let me staple the rest of these.
6'7". Well, this was.
The rest of you guys can just hang tight for a sec.
Go away.
Someone drew.
And David, are you guys fine with comic copies, right? David, are you guys fine with comic copies?
Mr. What I was trying to say about the statement problem.
Yes, tell me, yes, yeah. You're good.
If we know that we have.
Yes.
Points where the X value is the same. Oh, right. Between the Y and the X.
There are no line size.
I mean.
Exercise. Yes, why not? There are no line size.
I just totally read it with the Y intersection.
Well, no, you could have like 2 points in X value, like 6 times 6 and 0.
I had.
Oh, the average of that, yes, you're right. No, you said 6 0 to 6 6, right?
No, I said.
You have 6 times 0 to 6 times 6.
No, I did 0, 6 and 6. I just totally misread the.
Oh, no, you're right. That would be. You're right.
It's just. I did it with.
Right. No, but what you did was you found a symmetry
Right,
between
right.
the 2 points, and that's 3, yeah, you didn't have to do that slope, yeah. That's fine, no, actually, that's clever. And now you have a center, you found the radius.
I don't even know what. I got it.
Well, no, it was really more complicated. I did.
Wait, is this wrong? Because.
No, you're not, wrong, you're right, correct.
Okay, so this.
No, your reasoning is correct.
The Y, it is.
You're fine.
I'm Persian instructor.
Yeah, I now understand what you did. I didn't use symmetry again, so.
Yeah.
Yeah, definitely on your own. Okay, but you're still more detail.
You want me to tell your students?
Yeah, if you can, yeah. thanks. Give me 1 second, she's got tested, let me take her, yeah. Okay, I'll help you out. Give me 1 while I get it up to 2 point micro, okay, yes, go ahead. Sebastian.
So it's like,
Go
you
Sean.
find what I did was I found the center, and then I said that I know that you have a coordinate, which is gonna be some, like, on the line, on the asymptote, that's like -a, like your center minus a, plus your,
There's something.
whatever.
Yeah.
Did that work? Like, you just use another point, basically,
Oh, yeah, you could, yeah, that works.
and then you solve it from there.
Yeah, let me check your work, I haven't thought that way, I think so,
I think that works.
yeah, okay. All right, so we're far away. Or just needs, yeah, what do you want, what is it that you want? Everything, okay, let me do this, I got you, I'll give you, some practice problems, and we'll start with graphing, yeah, that's good. Make sure you're full of that, and then we'll do simplifying,
Okay.
and then we'll do solving.
Uh-huh.
I think those are the big ticket items.
I don't know how I feel about the review ones too.
Yeah, that's a graphic, that's separate.
Okay. I was like watching your videos and like speaking it last night, and then I was just lost, and I can't tell what I was doing.
That's on the board here, let me. Get some lights. Alright.
Oh, wow. Wow. Yeah, you look so surprising today. It's raining. Because it's the week of the show and we have a theme day every day.
What's facing?
Dress is one of your favorite musical characters.
Oh.
Yeah, what is your musical character? I couldn't think of one, so I'm Jordan Baker from Gatsby. Musical. And my mom had this is the like floor-length dress right now. It's just tucked in. So,
way.
yeah.
Actually, kind of have a Wizard of Oz feel because of the emeralds, the kind of like green. Yeah. 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 That's what I was gonna say. Yeah.
Everything's fine. I don't know what I
It looks very theatrical.
How's it looking?
It's looking good.
Yeah.
Good.
Yeah, we didn't have to have a Saturday rehearsal, so that was always awesome.
Yeah, right. Okay. Okay. All right, so this.
Mr. Davidson.
Oh.
I see. I don't.
Yes.
I can cables, right?
Tables are good. Okay, actually, I
Hold on
want
one
to.
second, I just gotta
Okay.
So here's the deal.
get my
The table looks like this.
stuff organized.
But before we do that, we need to clear our assets.
Mhm.
So let's just do something.
Right? How you feeling about inverse trade? Confusing or
So what we've
I'm
gone
not comfortable
through,
with it.
not too comfortable?
so we'll
Yeah.
scrap X.
I mean, like.
I mean, we just started, so it's not, I mean, I'm not expecting you to be fully comfortable with it, but
Yeah.
just was wondering,
Uh.
hold on.
And then what's the horizontal asymptote? Yeah, the reason why is because when X gets large,
Mhm.
this fraction gets too much significant.
Okay,
And you're adding a super formula of 4, so that's why it's just 4.
okay.
So you can have horizontal line y is 4. That's the foundation of the graph. Perfect, good, great. So now what we need to do is now we plot points, right? But you're not with it. So you can plug 2, for example. So
It's
2 over
1.
1.
And then
2 plus 4 is 6.
Yeah.
So that's 13.
for what?
Great.
4-2.
4, yeah, so let's put just 6 there.
So you got the maximum.
So you put 2 comma 6.
You're great.
Mhm.
So replace your size. Sorry.
And let's put 3 in.
Um,
Uh,
1 plus 4 is 5. So the 3 comma 5. But you just do a little swoop.
Yeah.
And remember the asymptotes after the bar goes.
Uh-huh.
With that.
so you bump it like you.
And now it's the likewise when you're running too.
Yes.
Yeah, so this was like,
Yeah.
So -2 plus 4 is 2.
Yeah.
-2.
so,
0 comma 2.
but take a look at this and spend a minute.
It's like -1.
Let's talk about it. Have you had a chance to see what we've got right?
-1.
Plus 4 is 3.
Oh, yeah.
So you put it,
No, I was very happy, how,
We'll swoop.
you know, tell you been working and
Okay.
so.
And then I'll also ask for demand range.
Mhm.
So it's pretty clear that anything for X works except for 1.
Yeah.
So you see all real except 1.
Yeah.
It's pretty clear all Y right, you except for 4, it's all real except 4. And then we do want to say it's transformation from Y from the most basic. 1 to X.
Mhm.
Clearly it shifted 1 right,
Yeah.
like 4 up, you just see it as. And just make your own see it in most respects.
Okay, wait, so say the shift and stretch.
And also, yes. shifts-
So is the stretch always gonna be the top?
Correct.
Okay.
You say work stretch by that. So if you're looking at one of our X, I mean, it's hard to see the stretch, yeah, all the kind of the same,
Mhm.
but it is stretched. It's more obvious with problems or absolute value, but definitely the shift is obvious,
Yeah.
because this is kind of like, it's not like a cross, I mean, it's
Mhm.
kind of a shift product in school, but it's
Okay.
it's like,
Yeah,
a
cross
crossing,
there.
right? You're aiming at somewhere else, so. Okay. So same thing.
Wait, what's the shift and stuff again?
One
Stretch
right,
of
one,
2.
the vertical stretch of 2,
Uh-huh,
shift 1 right, shift 4 up.
okay. Because I was.
It correlates that.
Why is that one right? Because the next.
The reason because,
Okay.
so, no, you see a minus, counterintuitive perhaps, but the fact that like, what makes this 0 0, right? But what makes this 0 is 1.
Okay.
That's why, in order to get the same. 1 right. compared to this.
Or.
This is intuitive, because if I add a 4 to this, all the y values get added by 4. But in order to get the same impact that X would have on this, because X minus 1, you have to add 1 to the. Whatever X values have in this table, adding 1 to those would get the same impact. Impact meaning we produce the same output values.
Okay.
So it's always counterintuitive, yes. With that said. So root X on its own looks like this, where it starts at the origin. It's pretty obvious because you can't go less than 0.
I just looked over, right? It starts at 3.
So, y plus 3x equals
Right? No, not.
left.
No.
Exactly.
That's where it starts.
They won't count. Because you can't go left and negative.
Yeah.
You can go, you guys are for negative. You can go higher than -1. So now.
I have those.
That will, but we'll worry about that later. Let's make a table.
Yeah, when that question thing was on the other, like, for a test, no idea.
It's sweet, but we'll take care of itself. So, you're.
Yeah.
No, because I wasn't here Friday, I haven't been right yet, so it's my first time back. Yeah, so tonight I'll see if I can sneak him in through D period, but there's still a lot of like, yeah.
Oh.
Yeah. If I put in 0, because 0 is good, we're like root 1.
Yeah.
Which is
One.
1, -1 plus 3 is 2.
Uh-huh.
So see, it's raised on its own now.
Yeah.
So it's taken care of when I plug numbers, you don't have to do anything intentional about it. But if I put in another number, I want to put a number that makes it a perfect square, I'm not gonna plug 1 in, it's not weird, root 2. But 3 might be reasonable, so root 4 was root 4. And with -2 plus 3. So see, it keeps going down, so it takes care of itself, and I know the general shape, so I just kind of follow that. as we do it.
Okay.
Now my domain and range is pretty obvious, it's starting at -1, and going to the right. You can say that. And the range is pretty obvious, so I can read this down. So it's like,
Okay.
so don't overthink, you're overthinking, that's why you, don't overthink. And then, the shifts is easy, you go to 1 left compared to this, 3 up, and it gets reflected about the x axis. The negative always stay reflected. Yeah, okay, so that's, so if you feel comfortable, move on, or do you wanna do more practice of this, or?
It's either,
Back.
I don't know.
So
X squared, but.
Yes, let's say, I gotta take my pre-cal students, let me set you up on something, we
Okay.
can talk to these guys here,
Oh.
and, let's also do this too.
Yeah, I got that immediately.
Some more, yours like recooked.
Jordan Baker, guys. Oh, I guess so. This is a lower length dress. It just tucks into my pants right now. It is.
That is.
That's actually really important. I like.
Yeah, because you couldn't.
I mean, you can kind of see it in between. You can see the
Oh.
sparkle. Oh, I hate John.
So what, I gotta miss my head about faster. No, you're not. I disagree.
I have an 80 in the bathroom. And we kind of did stuff.
Who would do that?
We weren't slow. If I don't know what you're talking about, then who would do what? I did.
Oh, you went down 3.
Yeah, but also, what was like Charlie trying to get away from? I'm
You did
like, yeah, let me go. Go play.
Okay, try those right
I'll
now.
go to bed.
So we'll
Yeah.
try to, actually, let me do one more job here.
This is one.
That was kind of
That's one.
this is.
It's multiplied if this added to that, right? What? It's multiplied if this added to that, or it's opposite? I forgot. It's. Cause what if you like? Yeah. Add to 10. Okay, so it's. That adds to that, and you multiply to that. What do you mean, no?
Wait a sec here.
That's
Okay. Let's do a try. Okay, yes. so.
You know, so that one is going back to the reason we did it. Okay.
This one's.
Oh, there's my student, my student.
Oh, there's no variance. Oh, homework day.
Oh, plus 76.
Yes.
Seems like that was 76.
Okay, so if you have, let's say you have like an airplane, you have a wind as well. You have to do factors.
That would be one.
So it depends, yes, so you get an angle.
I didn't know it was in Twitch, like, how do I know it's not,
But
it's not, it's by four.
Those three, I guess it's not. I don't know how it's like. Those two together. I was thinking-
Wait, I know I did the box thing, yeah, but it's just like, there's plug this whole thing in, and it's like that.
Yeah, so
Oh,
you're
wait.
180.
What?
So this is number 13, right? Okay, so, or so you're gonna go with the bottom.
That's what makes it.
Okay.
So you want me to do the opposite, okay.
Yeah.
So here's- yeah, yeah.
No, but I
No,
have
not
to
too
do
good.
this one, it's plug on.
Yeah, that's what I was gonna ask.
So start here. Yeah, there'll be some just, yeah. So you go 148, so kind of like that roughly. So that's 90 plus an extra 58 degrees. So if you think about it, it's really negative 58 in terms of like, circle. Or if you go around this
See,
way,
I'm glad I did this,
almost
This.
because look, see, I did this the wrong way. Thank you, Sarah.
What do you think? Again?
I was kind of surprised.
And of course, race is the speed, right?
And then,
8.6 now.
yeah, I
8.6
mean,
times stuff like that.
I think it's
So that's what you're, or whatever. Yeah. Yeah, then the wind is 140. So
Yeah,
if
so
you're carrying 140,
Bunch,
just right.
bunch improved and.
So that's 90 plus another 50. So how far did it go around? It stopped short by 50 degrees. Because that's what I'm doing. So I'll be. No, you get back one, sure. But I'll be giving you
You can
bearings
check
where
truly.
you figure out where you truly land.
So that's just like north.
It'll be something that will be the North Shore block.
You know,
But it'll be something that's easy to identify. like
are you,
mental circle.
here to work through stuff with me or just
No, I
chilling?
have.
Of course, nothing to copy this. I
All
can.
right.
So that would be that. So as long as you know that, then you're fine.
And also the aperture test that we were doing.
So one of the, make sure that you add vectors. And
See,
then
I don't even
once
know
add
how you got
vectors,
that, too,
square
for that.
root, you do,
I'm struggling with this one.
square root of a squared plus b squared equals,
I don't think.
back to, yeah, and then there's tangent, some
I'm not
tangent equals b
talking
over a
about
or y over x.
Where?
Quite the example, and then I'll ask you. Yeah. See if you guys can start out.
I don't have a voice next to her, like, nothing related.
No, no,
I guess my feel.
No,
It's a hard picture, I don't know who she thinks we are.
I don't know, I'm not that.
But the things that I'm gonna ask you. Just like you did.
You guys play great and I think
Oh.
like we're 20 to 60 or whether they're when we get it, whatever.
I don't
You don't have to die.
It's
Yeah,
one verse.
And you
So-
guys,
I can't, I don't know.
they're gonna see fit. It's, yeah, you said,
Yeah, so the content is essentially, tackles and really just adding segments.
no, you, the last one you done.
Part is also, recognizing, triangle.
Yeah, we
No, that
did
was.
same thing actually.
Sure.
So for example, like
Oh, you are?
A plus U.
I'm trying out.
So if you think about it, you're adding
JV or
Yeah.
your?
I'm not sure.
so if you think about A is like doing a vertical.
Yeah.
And
Well, if you don't, we play the.
Yeah, you can cross those.
So.
It's kind of like.
Yeah, which is the last one that worked.
Yeah.
Oh.
Yeah. that's
Find
right.
it?
Yeah, how to get there. I forgot how to do that.
I can say, yeah, it's like it's going forward.
And you make little triangles, -12 and -1. What's your -12 and 1?
That's one.
And so then you plug them into a box. And then four, it has to be 4 hours. So this would have to
Oh,
be-
yeah, I guess, it should be a school to do that, but, yeah, there you go.
What? 4 hours?
Yeah, you can-
Oh, yeah, and then 4 X minus.
Oh, conference.
No, X minus.
Where was that?
Sorry. It was in,
Goodness, where you people.
So, but-
Good.
Look at the right now.
We really survived this right there, so.
Oh. When I put it in, I have one.
I think, well, that, yeah, that's.
Okay, fine.
Oh. Oh, so this is.
We did cross.
It should be negative.
No.
Well, that's a reference angle.
So it's this.
Yeah,
No.
that's the same thing.
I think the following answer was correct. I know, right?
How do you do that? I'm very confused.
Um,
by what this one is.
Yeah.
Where's that?
I wanna go over the-
Oh.
Yeah, actually, technically speaking, it should be.
Well, we get to the made out of this.
Alright, how are we doing?
Uh,
We'll see if I actually.
And then I have no idea what she's doing. Thank you.
Okay, so that's X plus 2.
Oh, yeah, because that's the way that cancels out.
Yeah, something more to cancel. I guess that's the best we can do. Yeah, something more to cancel. I think that's correct. Actually, that's not correct. Yeah, so something's off here. So you'll need to. Okay, so here's the deal. That's good. I like this. That's good. So here's what you can do. Always factor in easy stuff first. That's easy, right? These are a little more challenging. And that's good. He's doing this, all this jazz. That's great. But if you think about it, these problems are going to put with an intention that want the way things go well, right? So I probably suspect that okay, if X plus 2 hasn't gone away yet, maybe X plus 2 can report out of this. Just take a leap of faith. Okay. If there's a 2, this has to be -4. Get a negative, it has to be. And there's actually just has to be 3x, right?
Yeah.
Like 3x. And if I kind of check it out, okay, 3x equals 6x, -4x is -4x, 6x minus 4x, boom, got it.
Okay.
So I didn't have to do all this work, but I assumed that this is going to come out. And that makes sense. And then also to check my work, well, really easy to check the work. Plug in a hypothetical with x, that's 0. For example.
Okay.
That's becomes -4.
Yeah.
Plug in 0 over here, get 6 over -4 times -8 over -3. That's -48 over -12. Oh, what do you know? Oh, sorry, over 12. -4.
Okay.
So that's how you have confidence, feeling like, okay, I got this. It's because it checks itself out.
Okay.
So you want to add these layers of support for yourself.
Yeah, I don't-
Okay. Yeah, so let's take a look here. Right,
Also, should I take it in the class or in the ASC?
it's your call. If you take it here, I'll suggest it, but then you need an extra half hour. So you probably need to come by to lunch.
Okay.
If you want to do it, you can do it. So that's good.
Where?
I won't be able to help you too much, but I need to
Mhm.
help out with other students.
Yeah.
We have to teach
All right,
class.
see you, Connor.
Are you
Um,
doing class or what?
If you want to start during
I
lunch,
have extra time, so that's why.
but I think I haven't talked to other altitudes over here, but I'm guessing it's pretty short. I think we probably get most of it done. During lunch, and So here, because I have a free seat here, so I'll probably eat my lunch early.
Okay.
So if you come by and start lunch, I can get started. So you get lunch, come over here. I think that's fine. I don't know. Let's see. Hold on a sec. How do you get X plus 2?
I don't remember what the original thing
Okay, you
was.
see multiply back, you multiply top by X plus 1, right?
Yeah, but
It
then,
comes 3x plus 3.
yeah, but there was something else here.
Can you erase it?
Oh, no, I just put 3 up there, I believe.
Oh,
I just had 3 up there.
okay.
Yeah.
Oh, then I'm-
Yeah, we go and redo it. Yeah, that's not correct.
How'd that happen though?
Hold on. Yeah.
No, like, how did you do that? Because you want to get the same common denominator.
Yep.
I know, that's why I'm like, I see now.
Oh.
You wanted to get the same common denominator.
Mhm.
In this sense, like,
Right.
So, sorry, I just want to clarify, so here's like.
Correct.
For like.
Yeah,
Oh,
exactly. Pythagorean theorem. Right.
And then A plus B plus C.
Because you told that. I'm told that this is.
Why should you make big X plus 1 too?
So deliberately set a pregnant in 3 seconds.
Oh.
What A plus B is erased as the first station, B plus B is erased as the second, this model.
Oh, okay.
That's what,
This-
that's the skill, it's not terribly obvious.
Oh, so you just multiplied it by it,
Awesome.
and you did
You
that,
have to make.
Would you- and then I did,
But make sure, it's second.
oh, you just cross multiply,
You find.
X plus 1, or X.
Because you told the radius, so okay.
Yeah, I know what you mean, yes, okay.
Wait.
I'll just. I believe in you. What class do you guys have this week? I have a religion test, and then immediately followed. I can trust right now. You.
The what's us?
Yeah, I got a history quiz.
Is it a good test?
There was one that today. Was today.
What do you have?
Writing a response.
You're unsure.
Yeah.
I forgot.
Good one. Yeah, right, there's a lot of work there.
Could you
Yeah.
real quickly do like one of those like platforms, like one of the like.
Okay, so
I'll,
what do you
like,
get? What do you get? The X equals 1?
Yeah, I see.
Hold on, maybe let's just see what happens. Okay, so you have 3x plus 3.
Yeah.
plus 4x
Oh, okay,
equals 10.
never mind, I forgot.
Yeah, so 7x equals 7x should equal 1.
Okay.
Yeah, because here's the deal. The denominators will all cancel because now they're all the same. You made them the same.
Yeah.
So, okay. Well,
Can you do what?
yes, let's do that. Yes. Literal equations, yes.
'Cause I could do.
That sounds good.
But like, when it's like this, I get lost.
Okay, so multiply by e.
Mhm.
Right?
Yeah.
And divide by a.
Okay, yeah.
That's it.
It's right.
Because your goal is to get this by itself, so whatever is next to it, do the opposite. So if you divide it by something, multiply. If you multiply, divide.
Yeah, but then there is some, because I was doing the delta, and then it said like
Delta's got some crazy ones.
4 and like 1, and it was just 1/2, and then I multiplied by 2.
Here, let's pull Delta Math right now. Let's take a look at it. Oh shoot, was I being recorded this whole time? Oh my goodness.